Hello, my name is Robert Smith, and I'm with New River Community College. And today we're looking at the common ion effect on solubility at equilibrium. So, the times that you would see that is if you have an ion that's going to be used during the precipitation process, but is also exists in solution as a non-precipitant, something that is completely soluble, like silver nitrate. So in this case, we have calculate the solubility of silver chloride in a 5.6 times 10 to the minus 3 molar silver nitrate solution. So the steps for this, first of all, you want to recognize that silver nitrate, we can write that up here, so AgNO3 is going to be in equilibrium with silver plus NO3 minus. So the concentration of silver nitrate is also the concentration of silver. So our Ag plus, our initial concentration of Ag plus is 5.6 times 10 to the minus 3 molar. And now for the silver chloride, we want to do what is effectively an ice problem. So we have AgCl, which is a solid, and that's going to go in equilibrium with its ionic components, so Ag plus Cl minus. And because it's AgCl is a solid, we don't really worry about that during the ice problem. We're only worried about the aqueous species. So our initial for silver is 5.6 times 10 to the minus 3. But for chloride, we start off with nothing. And then our change is going to be plus S to both species. So at equilibria, silver ions are 5.6 times 10 to the minus 3 plus S, and chloride is S. Okay, so we can set up our KSP, our solubility product, which is equal to 1.6 times 10 to the minus 10 as products over reactants. So in this case, it's simply going to be the products because the reactants are solids. So 5.6 times 10 to the minus 3 plus S times S for our chloride. So this is silver and this one's chloride. Okay. We can, if we assume that S is going to be something very small, which it will be, we have that ability. In this case, we can just take this term to be approximately 5.6 times 10 to the minus 3 times S. So it's just S. So we're just making the assumption that this component here is no longer plus S. It's just the initial concentration. So we're saying that silver is not changing concentration that much. And the result when you do that, S will be 2.9 times 10 to the minus 8 molar, where silver does not change much in concentration. So really it's the addition of chloride that is going to cause, the inclusion of chloride that's going to change how much precipitant you form and the solubility of it. So to find the solubility of silver chloride in this silver nitrate solution, we simply take our S, which is the concentration of silver, concentration of chloride ions, and we multiply it by the molar mass of silver chloride. So 2.9 times 10 to the minus 8 will times 143.4 grams per mole, and this is molar. Molar is moles per liter, so the moles cancel, and we're left with grams per liter. So it's 4.1 times 10 to the minus 6 grams per liter, which is also 4.1 micrograms per liter. So you can do it either way, unless you're directed to do it as grams, specifically grams per liter, in which case it's 4.1 times 10 to the minus 6 grams per liter. So this is the solubility of silver chloride in a silver nitrate solution at the concentration given.